All right, in this video, we will cover fuel pumps as well as different style fuel pump designs. We will also go over basic components that you'll find on a fuel pump assembly, as well as operation, and then some basic testing and diagnosis to go along with that. So here we have three common automotive fuel pump assemblies. These are called fuel pump assemblies as they contain the pump inside of a housing, as well as the sending unit, which would be these floats right here. The sending unit is in here for the fuel level sensor, and then you also have a fuel tank pressure sensor as well. So these come as an assembly. You have two different styles we're looking at here. We have a return style, which are these two. The most common way to identify them is the fact that they have over 2 ports going to the pump itself. So on this one, for example, we have, if you follow this hose, we have fuel coming from the pump, which would go to this grommet right here, and that goes to your fuel rail, to your injectors, and then excessive pressure from the fuel rail will be diverted all the way back into this port right here, which goes back into your gas tank. On this one, you notice there's only one port right here, and fuel is pressurized and regulated inside the pump itself, and no fuel returns back to the tank. So you will notice this third port on most fuel pump assemblies is evap or pressure related, and that is true on this pump. If you notice, we have a one-way check valve here, and all that does is allow for air to be drawn into the gas tank when fuel levels drop, so the tank does not create a vacuum and squeeze itself. The reason it's a one-way check valve is because if air builds up or pressure builds up in the tank, you don't want those hydrocarbons to be released. That's the job of the evap system. So we can pull air in, but we can't let air out because that air will be contaminated with hydrocarbons. All right, we're moving next to the fuel pump motor itself. On this assembly, it is this unit right here, and you will notice there is a sock sticking out of the bottom. Now, this is not the fuel filter. This is just a sediment filter, more like a pre-filter that just makes sure all the sediments in the bottom of the tank does not get caught in this pump itself, because this pump is sitting at the bottom of the tank. Just a little free insurance for the fuel pump before it goes to the filter. So the next component we're going to talk about on the automotive fuel pump assembly is the sending unit itself. This right here is the sending unit assembly. It starts with a flotation device, which is connected to a rod that is connected to a potentiometer, which is just simply a variable resistor. The PCM will give this potentiometer usually 12 volts, and as the flotation device floats with the fuel level, it will alter the resistance going back to the PCM. That changed resistance is what the PCM will interpret as the fuel level and will display on the dash. All right, guys, another thing I forgot to mention on these fuel pump assemblies are the springs on each side. And you'll notice these on a lot of assemblies, and all these springs are for is just to make sure that the pump is at the very most bottom of the tank. So the actual height of the pump assembly is taller than the gas tank, so you have to compress those springs down in order to bolt the pump into the tank. All right, so here's a quick explanation of what I meant. So here we have a fuel tank that is cut out right here, and you can see how this is higher than the fuel tank itself. So when I would go to install this in the tank, I would push down and then bolt this in. And what that does is create constant pressure on this, keeping it at the bottom of the tank at all times. All right, so we have this cutaway from an 03 Honda. This is a fuel tank someone cut up at the tech here, and it's very good for this video. It shows a good intake view of the fuel pump itself. And you'll notice this fuel pump is different. It doesn't have as long of springs like this one does, but there still is a spring in there, and this pump is under constant pressure held to the bottom of the tank. And that's pretty much it. We have our float here, but this is a great view of what the pump looks like inside of the tank. All right, I've drawn a simple diagram here of a return style fuel delivery system. We have our basic components, our fuel tank, our fuel pump, fuel lines, and our fuel rail. And we know this is a return style because we have our fuel return line right here. So just for basic operation on how this works, we have green, which represents room temperature fuel, which is pulled in through our pump, through our fuel line, and to the fuel rail, where it is pressurized and used for combustion through the fuel injectors. From there, we have the excess fuel, which goes back into our gas tank for reuse. This is the function of the return style because the way it regulates pressure is by sending excess fuel that it doesn't need back into the gas tank. So if there's a given condition where it doesn't need as much fuel as it has, it will just get rid of that fuel, send it back in the gas tank, it'll use it up later. So that being said, this is the biggest drawback of a return style system because a temperature change occurs in the fuel rail and the gas gets really hot in the fuel rail. Now usually this is what you want for vaporization in the combustion chamber. However, we are sending that hot fuel back into our gas tank. And what we know is that sending hot gasoline into a gas tank, letting it slosh around, produces a lot of hydrocarbons. So again, that is the biggest drawback of a return style system, is the increased emissions in hydrocarbons. So we have then switched over from a return style to a returnless style to eliminate those excess hot fuels coming back into the tank, creating hydrocarbons. All right, so here I have a simple diagram that I sketched out of a returnless style fuel delivery system. So you will find this on all new cars today. This is the future as far as fuel delivery systems. This is the best we've got at the moment. So what's different than a return style fuel pump on this returnless is that you simply don't have the return line back into the gas tank. So fuel that is drawn from the tank will never see the fuel tank again. That is the biggest takeaway from a returnless style. And the biggest advantage of a returnless style, especially over a return style fuel pump, is that you don't have that hot pressurized fuel from the fuel rail going back into the gas tank, which, as mentioned before, really increases your hydrocarbon output. So regulating fuel pressure in the pump and giving the car just the amount of fuel pressure it needs at any given time eliminates the need for that return line and thus decreasing hydrocarbon emissions. I have this demonstration set up here for you guys. This is a fuel pump assembly that we've been working with, and I have a bin full of water, which is going to simulate the pump being in a gas tank full of gas. Now what I've done is I've connected the power and ground on this pump assembly to a 12-volt battery pack, which can supply it with 12 volts, which will hopefully turn the pump on and give you guys a live demonstration of how this pump works. So I'll go ahead and turn this battery pack on. You can hear the pump turn on. And it's flowing. So while I have this demonstration set up, I thought I'd show you how the fuel level sending unit works. So I've connected my ohm meter, which is on the ohm setting, to the two ports from this connector, which are connected to the potentiometer, these two wires right here. And we have our float, which is floating in our tank right now, or in our bin. And what I'm gonna do is I'm gonna fire this pump on again, and we can notice that as the fuel level goes down, or water level per se, that the resistance will increase. So here I go. I'm going to turn this pump on. All right, so now that we've pumped some water out of this bin with our pump, we can now see that we were sitting at around 105 ohms before, and now we're at 137. And just to show you guys, I can push down on this float and you can see it go up even more. So that's just a good test to show you guys how that sending unit works. All right, so one thing to note after that last test is that not all potentiometers are the same. So we saw when the level in that bin decreased, the resistance increased on that potentiometer, and you'll see on this one here is that it's the complete opposite. So as we increase the height, the resistance increases as well. And it's important to note this because if you're diagnosing one of these, you could be completely backwards and it could screw you up when you're diagnosing them. All right, so here's a screenshot I took from ProDemand just of how the pump operates given different criteria. So with key on, engine off, it will operate for a second. And then with the key on, engine running and cranking as well, it will operate all the time, which makes sense. So given that, we're gonna do a key on, engine off test to see if that pump gets power for a second. All right, after reading that, I've gone ahead and back probed our power from our ECM to our fuel pump on this connector. And I'm gonna leave it unplugged, it doesn't really matter. We're just testing to see if we have power coming to the fuel pump. And then what I'll do is I'll connect the other end of my test light to a ground probably right here. And then I'll turn the key on and we should see this test light light up for a second if this fuel pump has power coming to it. All right, so I'm in the driver's seat of this Nissan Sentra, and what I'm going to do is go ahead and turn this key on while showing you guys what I have set up back here. And you can see that the test light turned on for a second, so we do have power to our fuel pump. All right, so this next test I'm going to show you guys is just to test the health of the fuel pump itself. So we're going to do a resistance check on the pump. And so the first step would be to isolate the component. So I have our connector disconnected, and so our fuel pump is isolated right now. And then I have our positive and our negative leads plugged into where the positive and negative connectors for the fuel pump are located. And I have our meter on ohms, and we can see that the pump is sitting right around 0.91 ohm, which is good. And obviously compare these to your manufacturer specifications for the correct specs, but just with general knowledge, we know that around 1 ohm is good for the pump. Alrighty, so what I've done to set up our picoscope is I have our amp clamp at 60 amps connected to our power wire. This is the same wire that we have back probed, and I left it back probed so we can get a voltage reading on the pump as well as a current draw, and we should hopefully be able to see how this pump is operating. All right, so here is the waveform that we pulled on the picoscope for the Nissan Sentra. You can see the red, we're sitting around 12, 13 volts. That's battery voltage, so that is good. And this blue form right here is our current, and you can see it's alternating. And what I can do here is I'll label and show you guys, but if you see this pattern here, you can detect how many commutator bars are in this motor. So I'll show you guys what I mean. And on this one in particular, there are 9 commutator bars in this motor. All right, so this is a pattern from a different vehicle that has a bad fuel pump, and you can see on this current waveform, you can see the general up and down pattern, but within that, there's a lot of sporadic like up and down movement, and so this pattern in particular is a bad fuel pump.